Hello, and welcome to Part 3 of Construction Scheduling. This is Resource Allocation. In our last segment, we developed the schedule. Here, we are going to add some reality to the schedule by limiting our resources. This presentation will demonstrate a couple of methods for dealing with such issues. With virtually no regard for resource limitations, our activities are scheduled on an early start basis. Also, float, which is available on non-critical activities, is preserved. This is done by scheduling non-critical activities on their earliest start date. But limitations do come up on the project for many reasons. If multiple projects are going on, resources may be needed at another site. Labor may be limited by market conditions and a host of other reasons. Now, there are those situations where resources may be available, but the cost is so high alternatives are sought. Resources on the construction site can consist of many things: time, money, materials, personnel, and so on. When discussing resource allocation, it is addressing the distribution of resources that are limited. In other words, if our schedule was appropriate and resources were appropriate for each task. And now, resources are being taken away, more specifically, personnel resources. There is only one way to stay on schedule: pay overtime. If this is not an option, we must extend the schedule. But we want to do this in the most efficient manner. A big advantage of the precedent construction schedule is that resource allocation can be logical. The known limitations of resource allows an adjustment to the schedule to be developed while applying all of your available resources. There are two resource allocation systems. The first one we will be demonstrating makes the assumption that once an activity starts, it must be finished. In order to allocate the resources logically, there must be criteria for allocating the resources, as well as for qualifying which activities must be scheduled with the limited resources. Therefore, when allocating resources using this method, the following rules apply. First, schedule activities to start as soon as their preceding activity is complete. Number 2, if more than one activity can be scheduled, priority goes to the activity with the earliest late start. Number 3, if multiple activities have the same amount of late start time, priority goes to the activity with the least amount of total float. 4, if multiple activities have the same amount of total float, priority goes to the activity requiring the largest number of resources. 5, if multiple activities require the same amount of resources, give priority to the activity that has already begun. And finally, if no activity can be selected using the above stated rules, start the activities based upon their input order. For this resource allocation demonstration, we will be using the schedule we created in the previous segment. As you can see, there are a number of activities that can be run at the same time. As an example, activities B and C can go at the same time. Activities D, E, F, G, and H will also run concurrently. But to run activity B and C at the same time, we need 4 carpenters and 2 laborers. To run activities D, E, F, G, and H at the same time, we need 9 carpenters and 3 laborers. So imagine if our workforce is reduced to 5 carpenters and 2 laborers. Let's take a look. The first step in this resource allocation method is to do a forward pass and backward pass to determine the late start times for each activity. This was obviously completed in the previous segment. The next step is to schedule the activities in a bar chart format using the precedent network schedule. To do this, we want to use a rational, orderly, logical approach to determining which activities will go first and the amount of resources that will be required to complete that activity. Now, let's go ahead and get started. We are going to solve this schedule using the manual solution. Again, a couple of rules before we start. Once an activity begins, it cannot stop until it is complete. Also, our limited resources are 5 carpenters and 2 laborers. These resource limits cannot be exceeded under any circumstances. Our first step is to create the bar chart. We can do this in Excel or scratch it on a piece of paper. All you want to do is list the activities in the far left-hand column. So, listed under the word Act, short for activity, there are activities from our network schedule. A through M, and again, there is no activity I. The next 2 columns represent the amount of resources required to complete that activity. C represents the carpenters and L represents the laborers. DUR is an abbreviation for duration, the amount of time required to complete that activity as noted in our network schedule. TF represents the total float of that activity, and LS represents the late start of that activity. Next we see SCHED, which is short for scheduled. In other words, to do this logically, we want to mark each activity as we are able to schedule it. After the scheduled column is a series of numbers. Each number represents a day in the schedule, 1 being the first day, 2 the second day, and so on. At the bottom of the bar chart, we see carpenters and laborers. We will be adding in the amount of carpenters and the amount of laborers as required for each day's work. Now, once we fill in our known information, all of which is coming directly from the network schedule, the bar chart, or more appropriately, Gantt chart, it should look like this. We have now filled in the activity, the carpenters required for each activity, the amount of laborers for each activity, the duration, total float, and late start. Now, at this point, only the first activity can be scheduled. This is because rule number 1 is no activity can be scheduled until its preceding activity is complete. Well, as we know from the network schedule, activities B and C cannot be started until activity A is complete. Therefore, the only activity we can schedule at this point is activity A. So, the first thing we do is mark activity A as being scheduled by marking the schedule column with an X. Then we apply the resources to complete activity A. People do this differently. We'll put a 2/1, meaning 2 carpenters and 1 laborer, and we want to make sure we total our resources at the bottom of our bar chart. So on day 1, there is only 1 activity in progress, which requires 2 carpenters and 1 laborer, which obviously does not exceed our resource limits. When activity A is complete at the end of day 1, we can schedule activities B and C, because it meets rule number 1, which is their preceding activity is complete. Now, by scheduling B and C, we will not exceed our resources. We know this by looking at the resources required, 2 carpenters and 1 laborer for each activity. Obviously does not exceed our resource limits. We can go ahead and mark activity B and C with an X as they have been scheduled and fill in the resources required for the number of days those resources will be needed. And we're going to total those resources for days 2 and 3 at the bottom of the page. The reason we're only totaling days 2 and 3 is we may have the opportunity to schedule more activities on day 4 and 5 since we're only using 2 carpenters and 1 laborer on those days. So to review, activity B starts on day 2. Its duration is 4 days, so it's going to be in progress for day 2, 3, 4, and 5. Activity C is in progress for 2 days. day 2 and 3, both of these activities are using 2 carpenters and 1 laborer. So, let's take another look at our network schedule. Activities B and C are scheduled and underway. Activity B will be completed at the end of day number 5, and Activity C will be completed at the end of day number 3. This means Activities D and E cannot be scheduled until Activity B is complete, because you may recall, rule number 1 is, no activity can be scheduled until its preceding activity is complete. Therefore, activities D and E cannot be scheduled on day 4. This means activities F, G, and H are now considered for scheduling on day 4 because activity C will be complete. So, of activities F, G, and H, the activity with the least amount of total float is G. But we cannot schedule G on day 4 because we'll exceed our resources. Activity G requires 1 carpenter and 2 laborers. The total resource allocation is 5 carpenters and 2 laborers. Since 1 laborer is already working on day 4 on activity B, we have to move to the next eligible activity, which would be activity F. So activity D and E cannot start as their preceding activity, B, is not complete. Activity G would normally start next, but would exceed our resources. Therefore, our next scheduled activity will be F or H. Since F has the least amount of total float, it gets scheduled next. Furthermore, F requires 3 carpenters and no laborers, so we won't exceed our resources. Activity F is now marked as scheduled and will run on days 4, 5, and 6 with 3 carpenters and no laborers. Also, Activity B is now complete, which qualifies activities D and E for scheduling. Keeping with our rules, Activity E has the earliest late start but requires 3 carpenters, and that would exceed our resources, since F also has 3 carpenters. Therefore, we are going to schedule Activity D. Activity D requires only 1 carpenter and no laborers. So, let's go ahead and schedule Activity D on day 6 and take a look at our resources. A review of our resources show that we'll only be using 4 carpenters on day 6 and no laborers. Now, we've already concluded that we cannot schedule Activity E as that will exceed our resources, and Activity F is already underway. This means Activity G, which was previously bumped, needs to be considered for scheduling. Activity G requires 1 carpenter and 2 laborers, which will not exceed our resources. Therefore, let's also schedule Activity G on day 6. Let's mark Activity G as scheduled on day 6, and our resources are exhausted on day 6, so nothing else can be scheduled. But Activity D was only a 1-day activity with 1 carpenter, which is now complete. So if we look ahead to day 7, Activity E has the earliest late start, and its preceding Activity D is complete. Furthermore, it does not exceed our resource limit. Let's mark Activity E as scheduled. Since Activity E requires 3 carpenters and Activity G continues through day 9, we have no available resources until day 10. Of the remaining activities, H, J, K, L, and M, Activity J meets our criteria. Its previous Activity D is complete, and it has the earliest late start at 8. A quick review of our network schedule confirms Activity J has a complete predecessor, D, and it has an earlier late start than the other activities. Furthermore, K and M can definitely not be scheduled as they do not have complete predecessors. So let's go ahead with J. Activity J is scheduled, and it will start on day 10. So, on day 10, activity E and J will be running simultaneously. This will use all of our resources. Therefore, we cannot schedule anything else until day 12. On day 12, activity K meets all of our criteria for scheduling. Its preceding activity, J, is complete. It has the earliest late start, and it will not exceed our resource limit. Let's go ahead and schedule activity K for day 12. After scheduling activity K, the next activity with the earliest late start is activity H, and a quick review of our resources and preceding activities shows that there is no reason we cannot go ahead and schedule activity H on day 12 as well. Let's schedule activity H beginning on day 12, and let's tally our resources. Here, we can tally the resources all the way through day 17 because activity L cannot begin until activity K is complete. This is because of limited resources and not because of precedent dependency. And to finish off this resource allocation Gantt chart, activity L can begin on day 18 and will continue on day 19, while activity M cannot begin until activity L is complete. Activity M is a one-day task, meaning that even though our resources were greatly reduced to only 5 carpenters and 2 laborers, we only extended our schedule 3 days. Not bad at all. Now, let's take a look at a similar system of resource allocation, but this system allows us to adjust for changing priorities. As you saw in the previous system of resource allocation, there is no room to adjust the schedule when there is a change in priorities. This is because that system is scheduled under the assumption that once an activity begins, it must continue until completion. This system follows similar rules, but allows certain activities to be discontinued, to begin and/or complete other higher priority tasks. In this second method, the same rules apply with the exception of rule number 5, which states that if multiple activities require the same amount of resources, give priority to the activity that has already begun. Here, we will not be given priority to the activity which has already started, but instead giving priority to activities that meet the previous rules of allocation. Now, since we are following the same rules, activities A, B, and C will be scheduled just as in Method 1. This is because these activities are still the priorities based upon all the rules of application. But now, let's take a look at what happens after these activities have been completed. As we know from a network schedule on day 4, we cannot schedule activities D or E because activity B is not complete. Therefore, activity F, G, and H are eligible to be scheduled. So, when we go to schedule day 4, activity G has the earliest late start. However, it still breaks the golden rule of resource allocation. It would exceed our available resources. Activity G requires 1 carpenter and 2 laborers. So why not stop activity B for activity G? Because activity B is still the priority based on the earliest late start. Therefore, since we cannot schedule activity G, we are going to move to activity F. But the difference between this resource allocation method and the previous method is if we hit a point where activity G is the top priority, we will stop activity F. In other words, in order for activity G to become the top priority, activity B must be completed. So for now, let's go ahead and schedule activity F on day 4. Here, activity F is scheduled for day number 4 and 5, but activity F is a 3-day activity. But at the end of day 5, activity B is complete, meaning activities D, E, G, and H are all eligible to be scheduled. Based on the rules, The earliest late start is activity E. Therefore, we are going to go ahead and schedule activity E on day 6 and discontinue activity F. As you can see, by scheduling activity E on day 6 and discontinuing activity F, we will have available resources. In fact, we still have 2 carpenters and both laborers. Therefore, we have to look for the next available activity to schedule, and the activity with the earliest late start is activity D. So let's go ahead and schedule activity D. And again, activity D only required 1 carpenter. Therefore, we still have 1 carpenter and both laborers available. The next available activity to be scheduled is activity G. Again, because it has the earliest late start. So on day 6, we are going to schedule activity G. Let's take a moment and tally our resources at the bottom of our sheet. So on day 6, we've used all of our resources. So let's look ahead to day 7. On day 7, activity E remains the priority as it still has the earliest late start at 6. Therefore, we want to go ahead and schedule activity E to continue. And again, on day 7, we will have resources available. We have 2 carpenters and 2 laborers. Now, before moving on to the next slide, can you figure out which activity should be scheduled next? Pause the video or just let the video continue to get the answer. If you chose activity J, you are correct. Of the available activities that need to be scheduled, activity J has the earliest late start at 8. Activity F is still not complete. It has 1 day of work remaining, but its late start is 11 days. Activity G has also been put on hold, but it does not take priority over activity J, again, due to the late start criteria. Again, can you figure out what should be scheduled on day 8? If you chose to continue with activities E and J, again, you are correct. Activities E and J remain the priorities on day 8. And, just for the fun of it, what do you think should be scheduled on day 9? Let's take a look at where we stand. Activity E still has 1 more day required to complete its task. Activity E still has the earliest late start, so activity E continues on day 9. But we still have available resources. We have 2 carpenters and 2 laborers. Activity J had a duration of 2 days, so it is now complete. The activity with the earliest late start date is activity G, and activity G requires 1 carpenter and 2 laborers. Therefore, taking this time to knock off another day of activity G would be our next best step. Let's go ahead and schedule activity G on day 9 to run concurrent with activity E. But remember, activity G still has 2 more days that need to be scheduled. But for now, let's continue with day 9. There are no other activities that can run on day 9 without exceeding our resources. So let's take a look at day 10. And let's review the remaining activities. Activity F is still on hold and has 1 day of work remaining. Activity G, also on hold, has 2 days of work remaining. Activities H, K, L, and M have not been scheduled. Of these remaining activities, activity K has the earliest late start of 10 days. And just to bring back the original rule very quickly, rule number 1 is activities preceding an activity must be complete. Therefore, when we go to schedule activity K, its preceding activity, activity J, is complete. So, let's go ahead and schedule activity K. Now that we've scheduled activity K on day 10, we see we still have resources. So what other activities should we schedule on day 10? Pause if you want to review. If you said activity F, you are correct. Activity F still has 1 day of work to completion, and it has top priority after activities K due to its early late start of 11. Now, day 11. On day 11, activity K remains the priority with a late start of 10 days. But with the remaining resources, we can schedule another activity. In this case, it's going to be activity H. Activity H is next in the priority list, as all of its preceding activities are complete and it has the earliest late start of 12. So, let's go ahead and schedule activity H to begin on day 11. And as always, tally our resources at the bottom of our sheet to make sure that we do not exceed the 5 carpenters and 2 laborers. Looking ahead, there is no reason that we cannot complete activity H on day 12 and continue with activity K. Now, on days 13, 14, and 15, only activity K can continue. This is because activity G, which still has 2 days remaining, cannot be scheduled because it would exceed our resources. Activity G requires 2 laborers. We're already using 1 laborer on the priority activity, activity K. Activity L still does not meet rule number 1 of our criteria, which is its preceding activities must be complete. And a quick look at the schedule shows us that activity L cannot begin until activity G is complete, and activity M cannot begin until activity L is complete. Therefore, the remainder of our schedule should look like this. As you can see, we're going to schedule activity G on days 16 and 17, which will finally complete that activity. This opens the door for activity L to begin on day 18 and continue on day 19, finally completing the project on day 20 with activity M. This method also extended the schedule only 3 days. But the big difference between this method and the previous method is the flexibility provided for priority tasks. Now there's another scenario that occurs on the job site. That scenario is we are asked to speed up construction as the owner is asking for an earlier completion date, and though money is always an issue, the priority is the completion date. So you'll want to use these additional resources as efficiently and safely as possible. In our next segment, Crashing the Schedule, we'll reduce the overall construction time efficiently and effectively. And this concludes Part 3 of Construction Scheduling.